Welcome to my channel. Today we'll discuss about backtracking and also N-Queen's problem in this video. Now we'll discuss what is meant by backtracking. Already we have seen different approaches like dynamic programming, greedy method, divide and conquer. In divide and conquer, we are going to divide the big problem, otherwise split the big problem into smaller subproblems and obtain the solutions. Then we are going to combine all the solutions. That is divide and conquer. Next, greedy method. In greedy method, whatever we have done, we'll find the optimal solution out of feasible one. Next, coming to dynamic programming. In dynamic programming, whatever we have done is, it's somewhat different. Here, we are going to find optimal solution only, but instead of using the solution again and again, redefining the solution and again, we'll store the solution and restore it for future purpose. This is about different approaches we have discussed earlier before this backtracking. Now, coming to backtracking, what is meant by backtracking? What is meant by backtracking in general? Now, suppose we are following a strategy for your mid exams or term exams. Okay, you are following some strategy for that mid exams, reading, revising, and all. Now, suppose this will not work out here for mid exams. Will you follow the same for your external exams? No. You will change your procedure. Means you have worked on it. You will find that this is not actual solution, and you will refine something for your next mid exams or external exams. Means whenever the solution is not feasible, that means the solution whichever you are framing is not the exact path, otherwise the feasible or viable path, then you are going to find some alternative method. This is called backtracking. Okay, means whenever the solution is not feasible or viable, then you are going to backtrack the solution and find the other solution. That is backtracking. And when it will work out, only for there is no time limit for problems. If there is no time limit, because if some problems like job scheduling and all, we are giving some sequence and some deadlines, in that case we can't use backtracking. We have, when no time limit for the given problem, then only you can go for backtracking. Okay, now one of the most popular topic in your backtracking is N-Queen's problem. N-Queen's problem. In today's class, we are going to see what is N-Queen's problem and what is the solution we have found it out using backtracking. What is N-Queen's problem actually? Suppose this is very easy, but you have to concentrate more. Suppose this is a chessboard. We'll think there is only some X rows and usually 8 rows and 8 columns, something, some X and Y rows and columns, and it is always a square, means number of rows is equal to columns in your chessboard. What is N-Queen's problem is nothing but the row, whenever you are placing one queen here, N-Queens means number of queens. Usually what are the principles for queens in general for the chessboard? The queen can move vertically, horizontally, the queen can move vertically, the queen can move diagonally also. These are the different operations the queen can do. In such case, whenever the queen is, how many queens we can place in the given chessboard, I mean in the given cell, that is your N-Queen's problem. Now here, for example, we will take an 2 by 2 matrix, that is 2 queen problem. Okay, 2 queen problem means we should take 2 by 2 board. In the 2 by 2 board, suppose if you are placing Q1 here, next queen, since it is 2 queens, you are having 2 queens here. Next queen you should place in such a way that Q1 will not collide with Q2. No collision takes place. That means Whenever you are placing Q2 here, it will not work because it goes vertically and it will collide. Whenever you are placing Q2 here, it will not work. So it will collide. So here, if you are placing Q2 here, it will diagonally it will collide. So the n-Queen's problem will not work out for 2 and 3. You can check for 3 also. Now I explain about 2. Now we'll go for 4 Queen's problem, which is in your syllabus. What is meant by 4 Queen's problem? So here you are having 4 queens. You are having 4 queens. You have to place that in the board such that no 2 queens will collide. This is your given board. In that you have to place the queens, 4 queens in that board in such way. We are taking 4 by 4 board in that way that no 2 queens will collide. In that way you have to find the solution. That is your n queens problem, that is your 4 queens problem, whichever we are taking now. Now if this problem we want to solve, we are using a method called backtracking. Before going to this problem, let us discuss about state space tree. State space tree, I am writing short form state space tree or state space graph. It is particularly used to find the solution for the given problem with all possibilities or feasibilities. We will find all feasible solutions in backtracking. That's why we are going to use state space tree. This doesn't give only solution but also all possibilities of that variables whichever we are considering. That is your state space tree. Now coming to your n-queen problem. We are telling we are solving this using backtracking. So what is first step? Now this is, for time being, this is 4 queens problem. First one, in step 1, place Q1 in here. For understanding, we will consider only columns. This is columns, right? We will consider only columns. So place Q1 in first column. If you are placing Q1 in first column, this is first step. Suppose if you want to place Q2 in second column here. If you want to place Q2 in second column, we can't place Q2 here since collision will happen. That's why we will not consider that step. We are going to place Q2 here. Q2 here. Now coming to Q3, you can observe that Q3 can't be placed here, Q3 can't be placed here, Q3 can't be placed here because it may collide, right? This is diagonal, this is diagonal. So this won't give you solution whenever you are placing Q1 here and Q2 here. Now you have to backtrack and check other possibility of Q2. Since from Q2 the possibilities are not, we are not getting the exact possibility, we will backtrack and check other possibilities of Q2. Q1 you are placing here. Okay. Now we are backtracking to Q2 since the Q3 is not placed correctly. We have discussed whenever the solution is not viable, we are going to backtrack like this. Now Q2, we will place Q2 here. If you are placing Q2 here, then that is in second column. If you are placing Q2, next you can't place Q3 here since it is not considered. Q3 you can place it here, it's okay. Now we will go for Q4. Whenever you want to place Q4, Q4 can't be placed here, Q4 can't be placed here, Q4 can't be placed here. So this one also you have to backtrack. This is backtracked. Since it is already backtracked and you are placing, you are coming here, now you will directly go to the position of Q1. From there you will start backtracking. So you will change the position of Q1 in your step 2. Step 2, change the position of Q1. Q1 is placed in second column. Q1 is placed in second column. This is Q1. Now you are placing Q1 in second column. Now whenever you are placing Q1 here, the possibilities of Q2 you can't keep here, you can't keep here. So you are placing Q2 here. Okay. Now whenever you are placing Q2 there, you have these 3 possibilities. Either this you can't pick. So you are placing Q2 here, because this one it will be collided and this one is diagonal, this one is vertically hit by Q2. Now after listening this, now Q4 is left. Q4 position you can keep it here. So this how we'll find the solution for 4 queens problem by backtracking. Now we'll just revise once again. Before going to that, the solution set will be, we'll consider only column. This is second column. Next 4, this is first, and this is 3. This is your solutions for your 4 queens problem. This is the solution. Now before going to the state space tree, we'll once again revise it, then we'll go to state space tree. Now whatever we have done here is, you are placing Q1 here. I am writing the board again for your better understanding, so that it will be easy for you. So whenever you placed Q1 here, first step you are placing Q1 there, you can't place Q2 here and here, you are placing here. Okay, step 1. In that step 1, whenever you want to place Q3, you can't place here. So you will backtrack the position of Q2. Okay, after backtracking, what will be the position of Q2? This is the only possibility, right? You are writing here. After this, whenever you want to find the position of, after finding the position of Q2, now you will go for Q3. You can't write here, you can't write here, you can write here. You are placing Q3 here, but come next, whenever you can go for Q4, it's not possible for writing Q4 anywhere. That's why after coming to Q4, you will backtrack to position 1, that is Q1. Then you want to change the position of Q1, that is queen 1. Now coming to Q1 here, you can place Q2 here. It's possible only. Q3, this one is left. No collision will take it. So we will write here. Next Q4. At last you are writing Q4 here. This is the possible solution. Okay. Now we will draw the state space tree for the n queens problem. 2, 4, 1, 3, that is a solution. This is the root, that is empty. In state space, first we will start with empty only. The possibilities are here Q1. Okay, Q1 may be in first column, Q1 may be in second column, Q1 may be in third column, Q1 may be in fourth column. Okay, that is, you can write directly here also. 1, 2, 3, 4. This is the possible places of Q1 in step 1. Whenever Q1 is here, then where Q2 can come? Remind once again that it is not the solution we are finding all possibilities of q1, q2, q3, q4. Don't think that this is a solution. This is just state space tree which gives all possibilities of different variables, otherwise queens here. Since it is in q, first row is already filled, right? First column here 2, 3, 4 will be your next for position for q2. Next 1, 3, 4. Okay. Now suppose, now what are the positions left for q3? That may be 3 or 4. Here for q4 4, and for q4 another possibility is 3. This is how we'll fill the state space tree with all the possible solutions. Now you can just see, I'll write here 2, 4, here 2, 3. In my notes it's clear, just for your understanding I am drawing it again. Here only left one is 4, here 2, here 3, here 2. In that way you are going to fill all the possibilities. That is your state space tree. Now for checking whether the given element is diagonal or not, we have one rule. That is, suppose there are two cells I comma j and k comma l. These are the two cells we are having. How to find whether the given queens are placed in same diagonal? Then you have to apply the formula. Suppose the formula is modulus of row difference is equal to column difference. Then the given two queens are placed in same diagonal. We'll find an example for this. We'll write an example for this. Since if you are using 8 queens or 16 queens, the problem may be a little complicated. We are getting very big. At the time, it's difficult to find out whether the given solution, given the diagonals, the given queens are placed in diagonal positions or not. It should not be placed row vertically, horizontally, and also diagonally. So what we are doing, we are calculating the row difference and calculate the column difference. Now this is cell called 1, 1. This is cell called 2, 3. This one. Now how to calculate the row difference and column difference? So 1, 1, 2, 3. Take the two column. 1 minus 2 modulus is equal to 1 minus 3. You will get 1 equal to 2. So this is not equal to, that's why that is not the diagonal position of 1, 1 and 2, 3 cells are not placed in same diagonal. Suppose it is 3, 3, this one, and this is this one. How will we knowing 1, 1, 3, 3? How will you find out? 1 minus 3 is equal to 1 minus 3. 2 is equal to 2. So the positions are diagonal positions. This is way to find out the diagonal position. This is about your n queens problem in your backtracking. And one more thing here, whatever the solution we are getting here, 2, 4, 1, 3, the other possible solutions we may or may not get here. One more possible solution after finding this is mirror image of the same solution, that is 3, 1, 4, 2. If the queen positions are in 3, 1, 4, 2 also, you are not getting any collision happen. That is your one more solution. So mirror image of the solution. Okay, this is about your n queens problem and backtracking. Thank you.